Hi, welcome to Mrs. Thompson's classroom again. We are talking about trig functions, and in particular, we're going to talk about graphing these functions. And the most basic of them is sine and cosine. They both look like waves. And so we're going to start today with just looking at the sine function. And so we're going to start by looking at um, what the basic sine function looks like. And in order to do that, we're going to remind ourselves of some things about the unit circle. Okay, so when I start right here at 0 degrees, sine is going to be 0. Sine is also 0 over here at 180 degrees or at pi. Okay, so if I begin by marking my grid, we'll just say this is pi and this is 2 pi. Okay, pi is an irrational number, so I'm never going to get it precisely on a grid if I try to count by ones or twos, or so I just mark it. As long as the grid is marked, we can make the scale whatever we want it to be. I can even make the y scale different from the x scale. Okay. All right. So I'm going to mark these two zeros to start with. So at 0 and at pi. Now the reality of it is it'll also do this at 2 pi or 360 degrees. So I'll go ahead and mark that one as well. The other thing we know on the unit circle is that at the top of the circle, at 90 degrees, or at pi halves, it's equal to 1. So I'll mark that point. This would be pi halves, and I'll put that here. And at the bottom of the circle, we're at 270 degrees, or 3 pi halves. It'll equal -1. So that'll be right here. It'll equal -1. Okay. So, and then it just continues. If I could go around the unit circle over and over and over again, it'll just repeat that. So what's happening when I connect these dots is I get a wave, okay, and this is one period or one wavelength at 2 pi. Okay. But it'll continue that same pattern over and over again. So I'll hit 1 again, and then I'll come back down. Going the other direction, at -pi, it'll be 0. At -2 pi, it'll be 0. And I could find the peaks and the valleys in between. And it's going to continue this over and over. So our domain is actually all reals. Our range does get trapped, though. We notice the function never gets bigger than 1, and it never gets smaller than -1. Okay. Now that height of our wave, the distance of a wave from its middle to its peak, or from the middle to the valley, is called its amplitude. So its amplitude equals 1. And the amplitude is a distance, so it's always positive. The zeros are occurring at multiples of pi. Okay, where k is an integer. All right, and then of course the peaks and valleys are at 1 and -1. So let's take a look at how we might transform the sine function. So we've probably learned in algebra class before that we can take a basic function like, say, the quadratic x squared, and move it up and down or left and right, or even do a vertical stretch or shrink. These are called transformations of a function, and we can do those with our trig functions as well. So I'm going to put kind of all the possible types of transformations in here, and we're going to take a look at how that affects the sine function. So the first thing we have out here is this is our amplitude, because this is a vertical stretch. Okay. When we have a multiplier on the inside, this is a horizontal stretch or shrink. So which one is this? Well, it's actually a shrink, kind of backwards. When we put numbers on the interior of the function, it does the opposite of what it looks like. So this is a shrink by a half. So what that does is it changes the wavelength. It changes the period. So normally our period is 2 pi. So I'm going to multiply that by a half and get my new period. Now, when we add and subtract things on the inside of a function, this causes a translation either left or right. Now, we always want it to be x minus a number, so this is going to actually be going pi thirds to the right. Okay? And we call the left and right translations actually a phase shift. So let's take a look at what that means. So originally, this is my sine function. So I'll just sort of sketch it in here. Just put 1 period. Okay, so the phase shift to the right means it's going to take every point and move it to the right pi thirds. Well, if this is pi, this will be pi thirds and 2 pi thirds. So I'm going to move this point to the right, and it'll end up right here. I'm going to move this point to the right, and this one to the right. Every point gets moved to the right one. And then the 3, well, okay, now let's take this pi halves. Okay, so now the period changes. So let's think about what that does. So my start of my wave is still going to be at that pi thirds 0 that I just marked. But the end has to shrink in horizontally. So instead of being at 2 pi, which it normally was, I have to shrink that in half. So, but it also has to be affected by this pi third. So what we'll actually find is that my end is going to be my phase shift plus my period. So in this particular case, that's going to be at pi thirds plus pi. So that's going to be at 4 thirds pi. Okay, so now let's see, from my graph here why that is. Well, I need to take this ending, now that I have shifted it, my end, this would be my end, is at, sorry, this right here was my end. And that's at 1, 2, 3, 4, 5, 6, 7 pi thirds. Well, I need to cut that in half. Okay, and so we end up at, we end up moving this ending point in. This is now my end at 4 pi thirds. That also means this 0 here has to move in as well. Doesn't move quite as far because let's think about that. How would I find the middle point? The midpoint is going to be the beginning plus the end divided by 2. This is how we find midpoints. So that ends up being 5 pi thirds divided by 2. So that's 5 pi sixths. So I'm going to end up right here at 5 pi sixths. And I can find those 6. So this would be 1/6, 2/6, 3, 4, 5. Okay. All right. Halfway between the beginning and the mid will be my peak. And halfway between my mid and my end will be the valley. So I'm going to come up and down and up. Now my period was pi halves. Well, was pi. So that's 3 pi thirds. So to get another cycle, I just go 1, 2, 3, find the mid, find the middle of that, and find the middle of that, and I can connect the dots again. I can also go to the left, 1, 2, 3, find the mid, find the middle, and find the middle again. And I can connect the dots. So I can draw as many cycles as I want to. I can do it over and over. Okay? So let's kind of generalize this real quick of what we just did. So if I have a sine function like this. Okay. The A tells me my amplitude. The N here will tell me my period is 2 pi divided by N. And the B is going to be my phase shift. Okay, so let's do another one. Okay, so this time my amplitude is still 1. There's no number there, so it's understood. Okay, now this one looks different. Remember, the previous one had this parentheses here. So if I were to divide this 3 out, I would have to take pi halves and divide by 3 to get what's here. Okay. So if that n value is not divided out, we're going to have to do so. Now that does not affect my period. The period will still be 2 pi divided by 3. But notice my phase shift does end up being the pi halves divided by 3 to get that pi 6. Okay? And because this one is plus, that means this is going to the left. Okay, so, and then we're going to deal with this minus 1, which means I'm going down 1. So I'm going to do that at the end. Okay, so so the first thing I want to do is I want to be able to mark my grid. Well, my amplitude is 1, so I'm just going to pick a tick mark to be 1 and -1 on my y-axis. The next thing I'm going to do is look at my period and my phase shift in order to decide what my x-axis tick marks are. Now, their denominators are different, so I'm going to get them in terms of the same denominator. So 2/3 would become 4/6, and then I want to mark my grid in sixths. So this would be 2, 3, 4, 5, 6. That makes this pi. I'm going to go to the left as well with negative pi 6, 2 pi 6, 3 pi 6, 4, 5, 6. So this becomes negative pi. So now my grid is labeled. Okay, I can label a couple more. 3 pi 6 would be my pi halves. Okay, but my grid is sufficiently labeled. Now I start by plotting the point at the phase shift. This gives me my start. And sine starts at a 0. So I'm going to plot this point right here. Okay. Then I'm going to find my end. And the end is always the phase shift, which is -6, pi 6, plus my period. And we use that common denominator. So that gets me 3 pi 6, which is a half. So my end is here. Now my middle, I can look at my tick marks and just come into the middle and find it right here at pi 6. Or I can calculate it as the beginning plus the end, which I'll put there as 3/6, divided by 2. So that's going to get me 2 pi 6 over 2, which is pi 6. That's exactly where I plotted it. Now I need to go halfway in between there. Now those are actually what we call the quarter points. So I would take negative pi 6, okay, and the pi 6, and divide it by 2. So it's the beginning plus the mid, and divided by 2. And of course that gives me 0. And that'll be my peak. I find my other quarter point, which is pi 6 plus pi halves, and divide that by 2, and I get 4 pi 12ths, which is pi, which would be 2 pi 6, which is right here, and that's my valley. And now, I have one last thing to deal with, and that is this down 1. So I'm going to take every one of those points and move them down 1. And now I can connect my dots. Now again, this is not the entire graph, so I do want to continue the cycle on. So there were 2 spaces between the zeros. So I'm going to go 2 more and 2 more, and I'm going to go in both directions. Between each of those was the peak and the valley. And so going to the left, I'll do the valley first and then the peak, so that I can connect these dots. On both sides. And I have drawn now a full 3 cycles of this wave. Okay. All right, so that gives you an idea. So let me just again reiterate that this, if I have a sine function that is now looking like this, excuse me, this would be minus. This is my amplitude. My period is 2 pi over n. And my phase shift is b over n, because I have to divide that out. Okay, so hopefully that goes through that, helps you a little bit see how these transformations of sine work. And I will see you next time, and we'll look at cosine, and then we'll do tangent and cotangent and secant and cosecant as well. So I hope to see you in a later video.